Okay, today we're going to be working on a elapsed time problem. That means we're going to be determining the duration or interval between a start time and an ending time. So let's read our question. Christian's baseball game started at 8:15. When his game was over, it was 12 p.m. How long did Christian's baseball game last? So I'm going to underline how long did Christian's baseball game last. That means I need to know my start time and end time. The start time is 8:15. And the end time was 12 p.m. So, the first way I'm going to show you how to solve this problem is using a chart here. What I've done is made a 3-column chart. One that says hours, one that has minutes, and one that tells me what is happening. So, the first thing I need to do is to get to an even hour. You see how I am starting at 8:15? Now, this part is a little bit tricky because we're used to regrouping in base 10. But this is regrouping in base 60. That is because time is measured in 60 increments. For example, 1 minute is 60 seconds and 1 hour is 60 minutes. So what I'm going to do is get to an even hour where there's no minutes over here. So I'm going to take 15 and I'm going to subtract that from 60. Okay, so I cross out this, becomes a 5, 10 minus 5 is 5, 5 minus 1 is 4. So I get 45. So if I add 45, I get to that next hour. The next hour would be 9 o'clock. So over here, I'm going to put plus 45. Alright. The next thing we need to do is get to 12 p.m. Remember, that's our end time. So what I'm going to do is add an hour until we get to 12 p.m. So 1 hour would be 10 o'clock. Another hour would be 11 o'clock. And a third hour would be 12 o'clock. What I did was add 3 hours here. You see 1, 2, 3. So over here on what's happening, I'm going to put 3 hours. And I'll put minutes right here. Now that we got to 12 o'clock right here, we're going to look in our what's happening column. Well, I see that I started at 8:15. I added 45 minutes, so let me write that down. 45 minutes. And then I added 3 hours. So this is going to be the answer, 3 hours and 45 minutes. That's how long Christian's game lasts. Another way we're going to solve this question is using a linear timeline. The way I do that is I'm going to draw a line to start with, and I'm going to label this my start time. and that was 8:15. And the next thing I need to do, remember we need to get to an even hour where there's no minutes. So I will subtract 15 from 60 again, just to show you how that works. Borrow, this becomes a 5. 10 minus 5 is 5. 5 minus 1 is 4. So, again, we get 45. The way I'm going to show that is I'm going to draw another line here. And remember that when we add 45, that bumps this hour to the next hour. So, after 8 comes 9. So, this is 9 o'clock. The way I'm going to show that is I'm going to put a hop right here and then plus 45 minutes. Now that we got to 9 o'clock, we need to get to 12 o'clock. If we look at this analog clock right here, we can see that this is at 9 o'clock right here. If we count 1, 2, 3, it takes 3 hops to get over to 12. So it would go 1, 2, 3. This means that I would add 3 hours. The way I show that is the same as 45, but I'll make another mark here. And this would be 12 o'clock because that's our end time. And then I would add another hop, and I would label this plus 3 hours. Now, to figure out our answer, we would look at what we labeled our hops. So I see that I have added 45 minutes. And then I added 3 hours. So again, our answer is 3 hours and 45 minutes. That's how long Christian's game lasted. This is how you solve a elapsed time problem. Thank you.